Why fixing one problem creates another. Every solution feels like progress until it quietly creates a new problem, usually worse than the first. To understand why fixing one problem often creates another, we need to look at how systems absorb change. Problems rarely exist in isolation. They are symptoms of deeper structure. When one part is adjusted, pressure moves elsewhere. The energy that manifested as one dysfunction does not vanish when that dysfunction is addressed. It finds new pathways, new expressions, new points of emergence. Systems are not collections of independent components that can be adjusted separately. They are webs of relationships where altering one strand inevitably pulls on others. This interconnectedness is invisible during normal operations, but becomes brutally apparent when interventions begin. The naive assumption that problems can be solved without consequences reflects a fundamental misunderstanding of system dynamics. Every action taken within a system reverberates through the entire structure, creating effects that may not appear for months or years, but are no less inevitable for being delayed. This matters because modern systems are built around optimization. Identify the bottleneck, remove it, improve efficiency. Each fix is measured, targeted, and justified. On paper, the system improves. The logic is seductive in its simplicity. Problems are framed as obstacles to be eliminated rather than as information about system structure. Resources flow toward removing visible inefficiencies. Success is measured by the disappearance of specific symptoms. This approach delivers tangible results that can be quantified and reported. Managers celebrate improvements. Stakeholders reward efficiency gains. The feedback loops all reinforce the belief that problems should be fixed directly and immediately. The methodology appears scientific, data-driven, and rational, but rests on an unstated assumption that proves catastrophically wrong. That systems are simple enough to optimize one piece at a time without creating unforeseen interactions. At first, the results are convincing. Performance increases. Errors decrease. The original problem fades. Success reinforces confidence that intervention worked. The system appears healthier. Metrics that were problematic now show improvement. Complaints diminish. The evidence seems unambiguous. The fix worked. This immediate positive feedback creates powerful institutional momentum. The approach that succeeded once is applied again and again. A pattern emerges where every new problem triggers a search for a targeted fix. The organization develops expertise in solving specific symptoms. Specialists emerge who know exactly how to address particular types of dysfunction. This accumulation of fixing capability feels like organizational maturity, but it is actually the construction of a trap. The better the system becomes at fixing problems, the less capable it becomes at understanding why those problems keep appearing. But systems are interconnected. Solving one issue alters flows, incentives, and timing. What was once balanced shifts. Stress that was visible disappears, but stress that was invisible begins to grow. The redistribution happens through pathways that may not be monitored or even known. A change in one department affects another through shared resources. An adjustment in timing creates mismatches downstream. A rule that prevents one type of error makes a different type of error more likely. The complexity of these interactions typically exceeds the scope of analysis that preceded the fix. Problem-solving efforts focus narrowly on the specific dysfunction being addressed. The broader system context is acknowledged in principle but rarely examined in detail. This creates a systematic blindness to consequences that occur outside the problem definition. The fix succeeds within its frame while creating problems beyond that frame. This is where unintended consequences form. A fix reduces friction in one area, increasing load in another. A safeguard removes risk locally while amplifying it globally. The system does not resist change. It redistributes it. Because the original problem is gone, attention moves on. The new pressure builds quietly, outside the frame of the original solution. Metrics still look improved. The system feels smarter. Resources that were dedicated to solving the first problem are reallocated elsewhere. The success is documented and becomes part of organizational memory as an example of effective intervention. No one monitors what is happening in the areas that absorb the redistributed pressure because those areas were not part of the original problem definition. The displacement is invisible by design. The fixing process creates its own blind spots, ensuring that consequences emerge as surprises rather than as predictable outcomes of intervention, until the next problem appears, not as a coincidence, but as the shadow of the solution itself. As fixes accumulate, systems begin layering solutions on top of solutions. Each one addresses a visible issue, while adding complexity beneath the surface. The structure grows heavier, harder to understand, and slower to adapt. This creates a pattern. Problems are solved locally but displaced globally. Risk is not eliminated. It is moved. Side effects emerge far from the original intervention, often delayed in time. The temporal and spatial separation between cause and effect makes attribution nearly impossible. When a new problem appears, it is analyzed as a fresh issue rather than as a consequence of previous fixes. This prevents organizational learning about the true costs of intervention. Each generation of problem solvers inherits a system shaped by previous solutions, but lacks the historical knowledge to understand how that shaping occurred. They see current problems as evidence of insufficient fixing rather than as evidence of excessive fixing. The response is always to fix more, adding another layer to a structure already groaning under the weight of accumulated solutions. Mathematically, this reflects conservation. Pressure does not disappear. It changes form. When flow is restricted in one channel, it increases in another. When variability is suppressed in one area, it erupts elsewhere. The total amount of stress in the system remains relatively constant or even increases due to the overhead of managing the fixes themselves. This conservation principle is fundamental but widely ignored. Decision makers implicitly assume that fixing reduces total system stress, when in fact it merely redirects that stress. The redirected stress often becomes more dangerous precisely because it is unexpected and unmonitored. A known problem with visible symptoms is safer than an unknown problem with delayed symptoms, yet fixing systematically converts the former into the latter. The mathematics of system dynamics predicts this outcome reliably, but the mathematics is rarely consulted during problem-solving efforts. The danger lies in feedback. Solutions change behavior. People adapt to the fix, not the problem. New incentives form. Workarounds appear. The system evolves around the solution, often undermining its original intent. What makes this phase deceptive is improvement. Each fix works in isolation. Each metric shows progress. But the system as a whole becomes more fragile. Complexity rises faster than understanding. The gap between apparent health and actual resilience widens steadily. Leaders reviewing performance dashboards see success. Operators working within the system feel increasing brittleness. This divergence between measurement and experience creates organizational confusion. Who is right? The data showing improvement or the intuition sensing danger? Typically, the data wins. Intuition is dismissed as resistance to change or nostalgia for simpler times. But the intuition is often detecting real patterns that escape measurement. The system is becoming harder to operate, more prone to surprising failures, less forgiving of small errors. These qualities are difficult to quantify, but no less real for being unmeasured. Over time, the cost of fixing grows. Solutions require solutions. Maintenance replaces innovation. The system becomes reactive, not adaptive. Energy that could flow toward improvement is consumed by preserving existing fixes. Technical debt accumulates not just in code, but in policies, procedures, and organizational structures. Each layer of solutions creates dependencies that must be maintained. The system becomes a maze of special cases, exceptions, workarounds, and patches. New employees require extensive training to navigate this complexity. Institutional knowledge becomes critical because the system's behavior no longer follows from its formal design, but from the accumulated history of interventions. When key personnel leave, they take with them understanding that cannot be reconstructed from documentation. The organization becomes hostage to its own history, unable to simplify because no one fully understands what each piece is doing or why it was added. This is when fixing problems becomes a problem, not because solutions are wrong, but because they ignore the structure they reshape. The conflict peaks when the system becomes trapped by its own solutions. Every attempt to fix a new problem threatens to undo an old one. Progress turns into negotiation. Change becomes risky. This is the emotional breaking point. Decision makers feel surrounded by consequences they never intended. Removing a fix causes failure. Keeping it creates strain. The system can no longer move without pain. Proposals for change trigger extensive impact analysis as everyone tries to predict what will break. The analysis reveals so many potential consequences that change feels impossible. Yet, not changing also feels impossible because the problems keep mounting. The organization finds itself in a state of paralysis, unable to move forward or backward, trapped in a configuration that everyone agrees is suboptimal but that no one knows how to escape safely. Mathematically, this is a sign of overconstraint. Too many rules govern behavior. Degrees of freedom collapse. The system loses its ability to respond creatively. It reacts defensively, protecting existing solutions instead of addressing root causes. At this stage, blame is common but misplaced. No single fix caused a fragility. Each solution made sense in its moment. The problem lies in accumulation. Intervention stacked without re-examining the whole. This is why late-stage systems feel brittle. Small changes produce outsized reactions. Innovation stalls. Maintenance dominates. The system spends more energy preserving solutions than delivering value. The ratio of maintenance to productive work inverts. What was once a system designed to accomplish goals becomes a system designed to maintain itself. Purpose is gradually displaced by process. The organization exists to keep existing, not to achieve outcomes. The conflict is not between good and bad fixes. It is between local success and global coherence. And coherence has quietly been sacrificed along the way. The resolution comes when systems stop treating problems as isolated and start treating them as signals. Mathematics supports this shift. Solutions at last address structure, not symptoms. This changes how fixing works. Instead of adding layers, systems simplify. Instead of tightening control, they restore flexibility. Instead of optimizing locally, they evaluate global impact. Sometimes the best fix is removal. Removing constraints. Removing assumptions. Removing complexity that no longer serves a purpose. This feels risky, but often restores adaptability faster than adding another solution. The courage required for removal is substantial. It means accepting temporary degradation in specific metrics for the sake of overall system health. It means defending decisions that appear to make things worse in the short term. It means resisting institutional pressure to do something visible, even when the best action is to undo previous somethings. The deeper lesson is restraint. Not every problem needs an immediate fix. Some need observation. Others need redesign. Acting too quickly can lock in consequences that are harder to undo later. This restraint goes against every instinct in problem-solving culture. Leaders are rewarded for decisive action. Consultants are paid to deliver solutions. Organizations measure productivity by counting interventions. The entire institutional apparatus pushes toward fixing. Suggesting that a problem should be observed rather than solved is often interpreted as passivity or incompetence. But observation is active. It requires discipline to watch a problem without immediately trying to eliminate it. It requires wisdom to distinguish between symptoms that need immediate attention and symptoms that provide valuable information about deeper structure. The hardest skill in system management is knowing when not to act. Fixing one problem will always create pressure somewhere else. The question is whether that pressure is acknowledged early or ignored until it becomes the next crisis. Systems that survive learn this. They fix less, they understand more, and they change the structure before it forces change upon them. Subscribe to join the journey. Why?